Okay, hitting stream. We are live
Phones off.
in speed of spinny things. Come on, connection. Live.
Welcome back, folks, to the IES Conference 2019, Greg. Live stream.
Here we are with number 10.
Whew, that was a run.
It is a run.
We got to tell you first, before we begin, about our patron and sponsor for this event. We're very thankful and grateful for Andrew at Kurtzon Lighting. Go to KURTZON.com, baby. That's Kurtzon.com, Greg.
Specification grade. All of their product has tunable white. They're known for medical fixtures, vandal proof. They have far deep red 720 nanometers in their EL, TL, and KL offerings. Behavior health. They have anti-ligature fixtures. Vandal prone we talked about, public parks, prisons. They have fixtures for everything. They have 5-day quick ship. They have videos on their website. They have a Troffer retrofit kit for their fixtures, other people's fixtures. And they're going to all the shows that matter coming up. Light Show West Design Build Conference in Vegas and LED Specifier Summit in Chicago coming up. Check out their website, Kurtzon. You can't go wrong.
KURTZON.com. 4 generations, almost as old as Canada, 1898.
It's a long time.
Folks, you got to go to Kurtzon.com. That's KURTZON.com. Welcome to the stream, Bradley Slusselman.
Hello,
Right?
how are you today?
Did I get it right?
That's close enough.
So you're a senior researcher. What do you do every day?
Well, most of my day is spent just looking into the vision sciences and lighting sciences. I come from the lighting industry. I do work for a manufacturer, but I spend most of my time just looking into vision and lighting research.
So we participated in can I say your glare?
Yes.
Or the glare?
The glare committee's demonstration room today.
Yep. Yeah, and so you said you didn't have all the numbers crunched yet or anything. What are you looking for there, though?
Well, where we're at in the industry is that we have a few metrics that are indoor metrics that go along with discomfort glare. But in outdoor environments, like nighttime outdoor environments where you have street lights and parking lot lights and various different outdoor lighting, there isn't a IES known metric for that. For years, there's been the bug rating system within the MLO, or the TM15, I think is where it's at currently. But most of those metrics are based on the glare side of things anyway is based on a lumen-based metric. And what we are setting out to do with the discomfort glare in outdoor nighttime environments, which is the DGON committee of the IES, is to define a metric that can be used by the outdoor interested folks with lighting on how we can evaluate discomfort glare in those types of environments. And so that's what the committee is put together for. For the last 2 years, we've been working. We've got a committee of about 15 or 20 people from the industry, and we've been working on to try to answer that question. And I know that question's been out there for 100 years or more, but we're at a point now with solid state lighting. Seems to be more of a
it's sharper.
It's sharper. It's more discomforting.
Yeah, it is.
I think the masses will say that it just is. It's more discomforting and more disabilitating at night.
Sure.
And so what we really need to do is we really need to try to figure that animal out and come up with a metric that, one, gives somebody an idea on what it is that is discomfort glare, and that's the thing with discomfort glare is it's very subjective, and so everybody senses it differently, and so it's going to be very difficult to say this is what it is because it may affect you different than me than somebody else. And so what we're trying to do is we're just trying to stick a dart in the dartboard and saying, okay, this is what we think it is, come to consensus, and then get it out there. And then as we learn more, as we continue to do research and learn more, then we'll continue to bring it up to speed and get it more exacting. So we're really make it better than the current lumen-based metric that's in the bug rating system.
Now you brought up for the committee, you said night and exterior.
Yes.
Is it only an exterior issue? What about interior and during the day in your office?
Yeah, what we're doing is we're taking somewhat of a shotgun or somewhat of a rifled approach to this thing. We think that we need to start small and then gradually work into it. But we chose to use exterior environments, and we've kind of selected four main areas. Obviously, parking lot lighting. You get into some of the what I'm going to call the wall pack or building facade lighting sorts of things. You have we could probably throw in their roadway, although there's a roadway committee and they do a lot with the street lighting sorts of things, and so we're that's on the fringes. But then the other one is sports lighting. That's the market that I'm from, is a sports lighting market, and again we're just trying to find take those 3 or 4 pieces and start, and then from there we'll start adding in other pieces, maybe interior spaces, dark interior spaces where you're dark adapted. The big thing with what we're doing is you have to be dark adapted. And so if in our experience room, as you two saw today, we brought you in and we had you for a few minutes sit in a dark room, and so your eyes could get dark adapted, and before we did the experience. And so that's really critical because when you're outside, you're going to get dark adapted, and we just need to make sure that we're having your eyes at that level before we do any sort of collect any information on what it is that we're trying to figure out. So
on that experience that we had, just to explain, we were put in a room. We looked at what was it, a focal point? Is that what we called it? Or
yeah, there's a fixation point.
Fixation point.
Uh-huh.
And then there was a LED on the left. There was an LED on the right, and we had to say which one was more discomforting.
Yes.
And is it all about the number of LED chips? Was that the differences between the two?
What we tried to set up is we tried to get it so that we had different conditions. We had from small aperture sizes where the light was coming through a larger aperture to a smaller aperture, and then we had different luminance levels. And generally, the way that it worked is we had the larger aperture sizes had lower luminances, and the smaller aperture sizes had higher luminances.
Okay.
And what we wanted to get a feel for, what the idea of this experience room was about, was to try to get a feel for how the distribution of non-uniform sources at different luminance levels affected your perception of discomfort glare. And so that's why we did them in pairs. The pairs were all randomized. We had different randomized orders. And then we had 5 conditions, and each of the 5 conditions went against every other condition, either on the left or the right, so that it was not biased in any sense of the situation of the experiment. And it was simply a subjective deal. So you just basically said which one you thought in your mind was more discomforting, the left or the right.
And then you hope to get what after with the study that you did here?
Yeah. So what we're presenting here at the end of the conference is basically the counts. So how many? So if we had 5 conditions, how many times did the number 1 condition get identified as more discomforting than the one it was compared to? How many times did the second one and third one and so forth? So we just did strict counts right now to see if that told us anything. And then what we'll do once we have more time to go into the data and to really dig into it, we will start to look at the statistical analysis to see, okay, did we learn anything from it? So.
And so you guys are looking for a metric for glare. Is that the ultimate goal of all this?
Yeah, I think that's the ultimate goal of the committee.
Mm-hmm.
We set this up based on some work that's being done in the CIE at this point in time. A couple of our committee members are with the CIE. Some new findings with the way that the UGR modification is coming out, and I think that's either being released or it's going to be released here by the CIE. And so, as the chair of our committee, I have no shame at all in saying, if the CIE comes up with something that works for outdoor conditions like what we have, I'm okay stealing it or borrowing their stuff or using their stuff. Most of their work has been indoor based or in interior spaces where they've modified the UGR system. We just wanted to see if in our situation, if it could apply to dark adapted, more nighttime environments. And so we chose to kind of go down that path. We set our our setup was much in line with what they've come up with their work. And again, I don't know what it's going to tell us. We don't know yet, other than we just took some counts, and we'll see how they fall.
Do you think it's going to be something that will be like a number or a percentage, like it's 95% glare free?
Yeah, I know.
What we're shooting for?
When you're dealing with percentages, I think
Yeah,
I think it's difficult, because those
Right.
percentages.
99%, I guarantee it.
Marketing wins out a lot in that
Yeah.
game, so we want to stay away from that. That whole marketing game, and really come up with a solid number. So if you look at the UGR system and you say, okay, there's a range between 15 and 20 is one thing, and 20 and 25 is another thing. Hopefully, when we get done, we can come to some sort of a equal sort of range that is numerical, that we can then put out there and see what sorts of things happen. So. Right now, what we're up against again is we just don't have a metric through the IES for outdoor conditions where we can say, is that luminaire glary or is that one glary? Because everybody knows when they see it, but until you can measure it, predict it, and know what it is, what number to put to it, it really is a marketing game. It's okay. Mine's better than yours because mine's less glary. Well, what does that mean?
What do you think and Mike, this might be a question for you too, but in the marketplace, what percentage of fixtures do you see in the exterior that are glary?
All of them.
All of them.
Every single one. If you take in, and you know what, I want to, let's go back, because I want to ask you about the experiment before we move on to, outdoor fixtures, talking my anecdotal experience as a lighting distributor, right? What you did in that experiment, and this is an observation, it's not a criticism, but what I noticed that you did was you equalized the angle of attack, right?
Yeah.
So everybody put their chin on this level so that all of our eyes are at the same level, right? And I thought to myself, well, Brad's a lot taller than me.
Right.
I don't know how he's 6'4". What are you?
6'5".
6'5", right?
Yeah.
I'm 5'7". Okay.
Yeah.
So the angle of attack from a light fixture between you and I, just as two men, is vastly different.
Right.
So you may experience glare entirely different than I do, just in terms of your walking around it because of your height and because of my lack thereof. You understand what I mean? So what was the purpose of equalizing the angle of attack?
Yeah. So what we want to do is we
is that the right term?
It's the observation angle,
Sure.
position of your fixation point with respect to where the luminaire source is, or the source.
So just so the listeners know, we rested our chins on a chin rest. So everyone came into the room, and short, tall, wherever you were, you rested your chin on this thing and looked at a fixation point.
The issue is that this discomfort glare is so subjective, and so what we try to do is we try to get the variables as exacting as we can. So we positioned the light source. In this case, it was about 60 inches off the floor. It was aimed straight out. We wanted the eye to be in the same plane as the center of the luminaire, the center of the aperture. Our fixation point was, on Friday, we did a fixation point that was 25 degrees down from the horizon. Because as you've probably experienced, if you look directly at one of these things, you're going to have after images or blue dots in your field of view for a period of time. And so we didn't want that to happen. So we asked the folks specifically, don't look at the luminaires, because we don't want the after images to ruin this experience. And so we positioned the head so that we could keep at least those variables consistent. We positioned it on the same plane. We had the fixation point in the same place. In a scientific sort of setting, we would have one observer do the conditions. But we wanted to get people through. As you know, it took a half hour to get through the session. We had a wait list. I mean, we basically signed people up. We had 50 people go through each day, 48 people, because there were 6 per group. And we had yesterday at 11:30ish, we had our whole menu signed up for. Before the end of the day yesterday, we had all day today signed up. So if you came today and wanted to do it and you hadn't signed up yesterday, you were just out. There's just no way to get in. So we had a lot of excitement, but we also knew that we had to get people through, and we knew it was going to take time. And so we did 3 positions, and we set the chin rest so that they all converged on the focal point, which was that dot that was at 15 or 25 degrees. Again, we're trying to keep the variables to a minimum. We wanted to keep it as consistent as possible, because the subjective nature is good enough. I mean, it's hard enough to try to get your subjectivity, my subjectivity, and yours together. And
trying to put some rules in place.
Yeah, it's very difficult to do that. So we tried to fix as many variables as we could. And that's what the purpose of the chin rest was in the eye position.
Back to the question that I had before. Anything else in the study?
No, I'm good. I was just curious about why that was chosen and why not just have it random. But obviously now you've answered that. You know, when it comes to outdoor lighting, you know, in the interior space of, and this is going to take a little bit of a preface to get to my point, but by far probably the most deployed LED technology in the world is probably the 4-foot LED T8 tube. Okay, more of those are sold. Then more innovation goes on in that space, has happened in that. Like, how many generations of LED tubes do we have? It's like 7, 8, 10 in 5 years or something like that. So the reason why it is because the form factor is set. It's like a Jaga type thing, where it's like you have to, there's no point in making a different size tube because it's not going to fit. So everybody has to make a 4-foot tube with a bipin this, and it has to fit in this fixture, and it has to do whatever. And then you see just so much innovation happening within those form factors, right? And it gets better and better, and it works on the ballast, it works on bypass, it's flicker free, it's emergency with a battery in it, all this stuff starts to happen, all this great innovation. That was awesome for the interior person that just, hey, I'm renting this building, I just want to save energy. I think that backfired outdoor. And what they did was they said, this wall pack that was made for HPS, let's just make let's just jam some LEDs in there, and Bob's your uncle. But and I think, when you drove down a street and all the wall packs for HPS or even metal halide, when you drive, you can tell a metal halide wall pack because as you drive by it, the light kind of changes in it. Do you understand what I'm saying, Greg? It looks like there's as you walk by it, as you drive by it, you see the focal point of you can see the filament in a way. Like if you're a lighting dork like us, you can see that filament move across your angle as you're looking at it, right? Whereas the LED is like boom. And so that form factor setting of the average wall pack or the Cobra head is not, I don't think it's suitable for LED luminaires, for luminaires built for LED. And I think that's the reason why we have so much of a glare problem.
Yeah, no, and it's the other thing is and again, I don't know the exact number, but there's members of the committee that have done the studies on it. I know that that Yuli and Clarence, two of our committee members, when they were, Clarence is a professor at the University of Nebraska at Omaha, and then Yuli was a student there. But they did some luminance measurements of the LED source, and it's in the tens of millions for luminance of candela per meter squared of the chip itself. And when you have that small of a source size emitting that sort of punch
intensity,
it really it's hard to then knock down that glare. And so there's a lot optically that you can do with an LED these days. The TIR is the favorite. Everybody's kind of using a TIR. A lot of people are using a TIR. There's some other things.
What's TIR?
Total internal reflectors. They basically harness the lumens that leave that thing, and we want to get them going in a general direction. So they do a very good job at harnessing them. But when you're talking about that source and that luminance of that source, the TIR doesn't do anything by itself to kill that luminance, because you still need to throw that light in an outdoor setting. You need to throw light a long ways in some cases, area lighting sort of thing. And so when you do that, it's beneficial to get the light out there, but it's also, if you're on the receiving end of it, it's quite painful. And so it's what we have to get figured out.
We've turned a basic factory into a prison yard sometimes.
Yeah, right. Yeah.
You know what I mean? Like you're driving towards it at night. You feel like you're a prisoner, and it's like, don't move. You can almost feel that way sometimes. So
knowing that, what we got to do is we've got to figure out what are the thresholds, what should it be at, so that it helps the luminaire manufacturers come up with, hey, how do we address this now? How do we address this glare issue that is, that's notorious with these solid state fixtures. I mean, if you're not
Notorious is the right word. Notorious. It is notorious.
Yeah. And what I was kind of thinking is what do you notice the most when you look at an outdoor fixture that's glary? It's usually a wall pack, right?
Yeah,
that's the thing
much.
that stands out is a big glare bomb.
Or it's one of those ones that is mounted to the wall, but it's pointed up like this.
Yep.
Yeah.
You know what I mean?
Yeah, they've taken, and that's the other thing is, with the bug rating system, they look at, a fixed position. You got a backlight, uplight, and a glare position. It's all lumen based, but it's based on a fixed position. Well, if it's supposed to be operated in this position, and all of a sudden I need to get light out here, they tilt it up, and as soon as you tilt it up, it completely defeats the purpose of the bug system.
Yeah, sure.
And so that's the other thing that we've got to try to fix, because it really is it's kind of broken in that sense when that happens.
Yeah, and that's the one I noticed the most is the wall pack, but I think the one that you get most negatively affected by is roadway lighting. There was an example. I was driving just back from my kids' football practice, and I looked up quick, and it was a short pole light, maybe 10 feet, and it had this bomb in there. And then I looked down to turn, and I couldn't see anything. I was blinded, like totally blinded, turning left, and I was like, that can't happen. That's dangerous. So.
And that's the thing you just mentioned there is the other thing that goes into what you had asked before, and why did we fix that position there? In interior environments, there's very specific criteria on when you're sitting at a table or you're sitting at a desk, your fixation point is out here and the lights are clear up here. So they're a high angle above your field of view. What I have seen, what I've experienced, and what you just said is that in exterior environments, if you notice something that is glaring, what do? You look right at the darn thing and say, it's that one right there.
Yeah, it's true. And then you're blinded.
And then you're blinded.
Your pupils adjust or whatever, and you try to look back at the road, you can't see it.
You can't see it. So it's like the moth drawn to the light source sort of thing. It's your eyes when you're dark adapted and you're in an outdoor environment, and you experience something over here that doesn't feel right. Instead of looking away from it, you look right at it.
Yeah.
What is that?
What was the girl's, the lady's name that was helping you, assisting you, bringing the guests back and forth from the seating area to the experiment?
It might have been Naomi.
No, not Naomi. The other girl, shorter hair. Can't remember her name. Anyway,
Kate.
It doesn't matter. But what was interesting is that she kept reminding us not to look at the light.
Okay.
And I needed that actually.
Yeah.
She must have reminded us every time or every other time at least.
Yeah. So
remember, we want you to stay on that fixation point. It's like, okay, I forgot, because the first thing you want to do is look at which one's the most glaring.
Yeah, and we had to say that because as soon as you didn't look at it and you looked at the light source, I mean, you when we showed you the source, you couldn't physically adapt back quick enough.
Yes.
So you would already destroy your eye. Your eyes would have the blue dots, and you wouldn't be able to make a decision because you've got that after image on your retina.
Sure.
So, yeah, what we did is it was Kate in that case. She's a committee member, but the folks that were manning that position, we basically said, if they look at the source, we've got to throw the data out because it's not, whatever they tell us is not going to be accurate. And so they reminded folks, and they were very point to the point. Please don't look at it because it's going to be bad for you.
One more question about the experiment that just came in. Is there a relationship in my head? Is there a relationship between glare and color temperature?
There could be. I know there's some stuff with color temperature. It's a bad one because I know that the TM30 room was trying to get away from color temperature, and they're trying to go another route.
You know what I'm saying?
The spectrum,
5,000 K or whatever.
Yeah. So there's there is the potential to be. I'm going to leave it kind of open. I'm going to answer your question, but there's a possibility that yes, that the spectrum it is going to affect your subjectivity, your experience of glare.
Can I throw a theory at you?
Yeah.
And I want you to, as wild as this seems, we're creatures, we're evolved creatures, right? Whatever it is. They say some people throw out 200,000, somebody 3.5 million years old, or whatever it is, doesn't matter. So I think humans have a relationship to low Kelvin temperature at night from fire. I think that we evolved to feel comfortable, to feel safe, but still be able to sleep with the color of fire.
Sure.
And I think that 5,000 Kelvin or high color temperature outdoor lighting really offends that. And I think it's an anthropological issue. It's not like oh yeah, that can change. I think we have a deep relationship to this warm color at night, and HPS really mimicked that.
Right. I think that is, and I'm going to say a couple things here. The one that you're talking about is there's a preference for what you want. Certainly, do you want the warmer color temperatures or cooler temperatures, like in your home? If you're in your home, some people like, okay, I want this to be inviting and feel warm, and so I want warm color temperatures. Other people are like, just throw the blue ones in there; they look fine. I like it better. So, but to your first question. There is one of our committee members is really the expert in this from the committee standpoint. But there's the Kroitov curve. The Kroitov curve it basically says that if you are in lower light conditions, you're going to favor warmer color temperatures. If you're in a higher adaptive state or a more lit environment, you're probably going to favor more on the cooler color temperature or the 5,000, 6,000 K sorts of sources. So there is a relationship. There has been studies done on the relationship between the illuminance levels in the eye adaptive state of the eye with respect to whether you were going to favor more warm color temperatures or cooler color temperatures. That is something that there's a member of the committee that's really looked into that a lot. But I also think that for like streetlights, the big thing right now is it 3,000 K or 4,000 K or what is the best for streetlights? And I think that Kroitov curve thing holds true in a lot of cases. But I also think there's a preference point. I think there's people would prefer this or that. I've heard both sides of it. I've heard both sides of people liking the bluer streetlights, and I've heard a lot of people that don't like the blue.
Well, no, here's my so I sell light bulbs to end users every day of the week. Okay, so if you take a person and you put in 5,000 K lights beside 3,000 K lights, you say, which one's brighter?
Yeah. Okay. Yep.
5,000 K is brighter. Which one do you want? I want the white one.
Right.
Right. But then they really don't actually. Most people, if you didn't look up at the light and you walk through it, you realize that when you have more red saturation, you actually look better.
Right.
Like you look healthier. You know what I'm saying? Your girlfriend's prettier when you dim the lights and you get more red saturation. You know what I mean?
Yes, the skin tones are better.
Yeah, yeah. So it's like this idea of personal preference that kind of would almost offends you as a scientist. Like when you say it, I hear like a little touch of contempt in your voice when you're talking about it.
Well, if we had another hour, I could talk about a whole other topic. But I think it's there's research. I've done research and presented research on a previous project on. And I know that the LRC has done some work with it as well with the melanopsin receptor that in your eye, and there is a peak sensitivity in the blue range for that receptor, and there's a good possibility that receptor is responsible for how you perceive brightness. And so a lot of the research that's been that I've presented. Dr. Sam Berman and I and others were part of it. We've presented at the IES conferences and in various places where there is that receptor is sensitive to a part of the spectrum that's in the blue region, and that is what we found is it is responsible for your perception of brightness, perceived brightness. So I'm agreeing with what you're saying, but from a completely different research standpoint.
Right.
So it's obvious that glare is an issue, and,
and it's still an issue.
It's still an issue. And let's say you come up with a rating that now we can fix this issue. Are we going to go back to these glare bombs and fix them?
That's up to the consumer.
Right.
That's up to us, buddy.
But are they going to want to go back?
This and I hope Randy and Resky and Eric are listening to this one.
Yeah.
Because you're now I call guys like you an ivory tower guy. Okay. You're dealing with complex ideas and thinking them through, and you're kind of like I work for a lighting manufacturer, but I'm really a researcher, and I help them develop products, and then I go back into my cave and I do my experiments and whatever. You're like ivory tower guy, and not in a bad way, but in a way that I stand in front of customers every day, and I say buy this, buy that, buy this, buy that. And this podcast, Get a Grip on Lighting, is about connecting those two worlds together, so that people know that they can sell correctly, or that they can advise people correctly. Because at the end of the day, most lighting projects do not have a lighting designer. Probably 90% of lighting projects don't have a lighting designer. On top of that, you have most of the people selling to the end user, they're the decision makers, are contractors and distributors.
Right.
Like I would say probably at least 75, 80% of the
Yeah.
business is not spec'd.
Right. And I think to that point, I appreciate the world you live in because I used to work in that sort of world.
Okay.
And so it's not that I've been a researcher all my life, but it's also right now we all see it. We all see the glare bombs, and we are like, okay, how do we make sure we don't do that the next time?
Right.
And so what ends up happening is you come to the IES and you say, okay, how do we make sure that doesn't happen again? Can we get something in place so that
we're desperate for it? I want to know what the answer is.
And so then the IES finds a person like me that's glutton for punishment and wants to try to figure this out. And so we understand that it's not going to basically say, oh, okay, you've got to replace everything, but making future decisions, whether it's helping manufacturers understand when you develop a product, these are the standards by which we're going to live by, or you need to live by, because the consumers are going to want this. And so it gives them a sense of direction as far as what they're going to need to do to their luminaires to achieve what discomfort glare is or isn't. And then folks like yourself to say, okay, this is what's out there. And do you want that? Or do you want something that's a little more neighborhood friendly or, community friendly or whatever you want to call it, that's environmentally friendly, whatever it is, the word you want to use, that is going to control or going to manage discomfort glare more efficiently.
One more point before we call it. Does all this work on glare? Does it dovetail well with dark sky compliance?
I think so. I think, the MLO was designed, or not designed, the MLO was developed in a joint venture between the Dark Sky organization and the IES. And so they came up with that MLO sort of language, which was where the bug rating kind of started. But I think what I understand what the Dark Sky folks want is they want responsible lighting. They're not against lighting. They're not just about turn everything off and just have the stars. They know that things need to happen at night. They know that we are nocturnal creatures and we need to be able to move around. What they want, I believe, is to know that we're doing it the right way, that we are, that the industry is working towards minimizing the negative effects of lighting, and that glare is a negative effect in lighting, and so they're all about mitigating that concern.
Okay, well, Bradley Slusselman, been a pleasure speaking with you.
Oh, you're welcome. Thanks for having me.
Yeah, it was super fun. Much, Can't wait to see the results of your experiment.
Yeah, stay tuned,
folks. This is our last one from the Well, we're gonna do a couple more, but maybe we won't do them live. This is the last one, so we thank you all out there for listening. A couple hundred of you out there, maybe 1,000 or 2. I don't know. We're going to see what the numbers are. Listening to all this stuff. We want to thank our Patreon and sponsor, Kurtz On Lighting. Go to KURTZON.com, Greg.
Check them out. Over 121 years, 4 generations. Great company, specification grade fixtures. Worth looking at.
Michael and Greg signing off from Louisville. Thanks for listening.